Hello friends, welcome back to the next session of this linear programming problem. Okay, so till this class we have seen the linear programming. Okay, so till the last classes we have seen the linear programming. Now we are introducing one more term, which is a problem. I have already discussed what is the meaning of linear programming problem, and it is popularly known as LPP. Okay, so my first question is, have you used or are you familiar with this linear programming problem? Do we use this LPP in our day-to-day life? Okay, do we use this LPP in our day-to-day life? Okay, maybe your answer is no, sir. We have not studied this, so we are not familiar with this, and we are not using this, or we have not used this in our day-to-day life. But trust me, each and every one of us using this linear programming problem daily. Okay, but we don't know कि भाई उसको ही हम लोग LPP बोलते हैं. Now let's take a simple example. One of the simplest example I can give you is that, let's take one scenario that we have our final board examinations. Okay, we have final board examination, and अभी tomorrow we have the mathematics subject. मैथ्स पेपर है अपना बोर्ड का, 12th बोर्ड का मैथ्स पेपर है टुमारो, एंड वी हैव ओनली 24 hours विथ अस टू स्टडी टू फेस द फाइनल एग्जाम. वी हैव ओनली 24 hours with us, and we have to study 2 topics. Okay, let's suppose trigonometry, and suppose the what we can say is the stats. Okay, we will take these 2 topics. Okay, so what are the limitations you have is, you have only 24 hours with you, and you have to cover the 2 topics, mainly the trigonometry and the statistics. First tell me, what will be your objective? My objective will be what to score the maximum marks in this mathematics paper. Tomorrow's paper में हम लोगों को maximum marks gain करना है. So to get the maximum marks here in the mathematics, what you need to do is, we need to use the time as well as these topics very effectively. I need to spend this 24 hours in a very effective way. Abhi effective way means what? See here. Okay, our objective is clear. What is our objective is, I want to score maximum marks in this mathematics, and for that what we generally do कि भाई ये 24 hours है, तो 24 hours में से हम लोग क्या करेंगे, let's take, we give 24 hours का 24 hours तो नहीं पढ़ेंगे हम लोग, so let's take, we are studying for 20 hours. Okay, so what we'll do, we will divide this 20 hours in 10 hours and 10 hours. So 10 hours for trigonometry and 10 hours for the statistics. We generally do like this. Okay, and you know that there are so many topics in the trigonometry, 1 2 3 4, let's say there are so many, and in the stats also you will see this, there are so many topics, and you know very well that to cover each and every topic it takes at least 10 days. Okay, to cover this trigonometry full topic it takes at least 10 days, and same for the stats. Then what you will do, we have only 10 hours with us for the trigonometry. Then what we'll do, we will look into these topics, and we will select the units or the topics which are very easy for us. Okay, suppose first, second and third are easy for me. Okay, then what I will do, I will cover these 3 topics in these 10 hours. Okay, and same for the stats also. Let's take, I will be taking 1 2 3 4 5 topics from this stats, and I will cover in this 10 hours. What I am doing here, what I am doing is, I am utilizing this 24 hours in very effective way, such that maximum topics I am covering. Yes, are you getting? Maximum topics I am covering in these 20 hours. Okay, the maximum topics क्यों cover करना है आपको? Because ultimately आपका objective रहेगा कि मुझे maximum marks चाहिए. So this is how we do during the exam days. Okay, so this is nothing but the linear programming problem. Whatever you want to do, you want to have the maximum profit, you want to get the maximum marks, we utilize, see here, it is very very important, we utilize whatever the resources, we utilize whatever the resources available with us in very effective way, in a very effective way. Okay, so to get maximum marks in this example, to get the maximum marks, so this is nothing but the linear programming problem. I hope you have understood the what do you mean by the LPP. Okay, so that's why I told you कि भाई हम लोग डे टू डे लाइफ में यूज़ करते हैं. Let's take one another example with which also you will understand it in very detail. Suppose you get 5,000 rupees as a pocket money every month. Okay, every month you get 5,000 rupees as a pocket money. Now what will be your objective? My objective is that भाई पूरे महीने में मुझे 5,000 स्पेंड करना है, उससे ज़्यादा 1 रुपये भी नहीं चाहिए, कम चलेगा बट ज़्यादा नहीं चलेगा. ओके, सो व्हाट यू विल डू, वी विल स्पेंड ईच एंड एवरी पिनी वेरी केयरफुली. ओके, गर्लफ्रेंड रहेगी तो गर्लफ्रेंड के ऊपर थोड़ा खर्चा कम करेंगे हम लोग. ठीक है, और एग्जांपल बॉयफ्रेंड रहे तो बॉयफ्रेंड के ऊपर खर्चा कम करेगा. ओके, सो मे बी लास्ट 26 डेज को क्या होता है, डेट्स को क्या होता है कि पैसा बहुत कम होता है अपने पास, तो उन इन दोज डेज ऑल्सो वी थिंक वेरी वेरी इफेक्टिवली दैट हाउ टू स्पेंड दोज रिमेनिंग अमाउंट. ओके, सपोज लास्ट 10 डेज में, सपोज इन द लास्ट 10 डेज ऑफ द मंथ यू आर रिमेन्ड विद द ओनली वन सपोज 500 रुपीज़, देन व्हाट यू डू, बहुत सारा खर्चा करना है आपको. ओके, गाड़ी का पेट्रोल रहेगा. ठीक है, ओके, चाय पानी नाश्ता तो होते ही रहता है. देर आर सो मेनी थिंग्स वी हैव टू डू. ओके, ये पेट्रोल रहेगा, हाँ, चाय पानी होगा, और क्या होता है भाई, मे बी यू हैव द बुक्स यू वांट टू परचेस. ओके, और मोबाइल का रिचार्ज रहेगा. सो देर आर सो मेनी थिंग्स टू डू इन दिस लास्ट 10 days. Now what you will do, you decides the priorities. We decide the priority on which things I should spend more money to achieve this objective. 5,000 rupees every month मुझे spend करना है maximum. Okay, so this is what the linear programming approach. Okay, so I hope you have understood this. We will take one simple example which is there in your textbook, and from that we will understand different scenarios. Okay, so let's take that example. Okay, so first example is, see here what type of scenarios or the linear programming you may get in your exam. So you can relate this with your day-to-day life. Okay, see here, very beautiful example it is. A toy manufacturer produces bicycles and tricycles, each of which must be processed through two machines, machine A and machine B. Okay, machine A has maximum of 120 hours available and machine B has maximum of 180 hours available. Okay, manufacturing a bicycle requires 4 hours and machine A and 10 hours on the machine B. Manufacturing a tricycle required 6 hours on machine A and 3 hours on machine B. Okay, if the profit are 65 rupees for a bicycle and 45 rupees for a tricycle, formulate the linear programming problem to have the maximum profit. See, this term is very very important. To have the maximum profit, we want to form a linear programming problem. See, this question is related to this first example. What was your objective is to get the maximum marks. अभी ये मैन्युफैक्चरिंग का ऑब्जेक्टिव क्या है, ये मैन्युफैक्चरर का ऑब्जेक्टिव क्या है कि भाई मुझे मैक्सिमम प्रॉफिट चाहिए. ओके, सो प्रॉफिट कहाँ से मिलेगा, प्रॉफिट मिलेगा मुझे बाइसिकल और ट्राइसिकल से. सो लेट्स राइट डाउन दोज बाइसिकल्स एंड ट्राइसिकल्स हियर. So suppose we have this is as a bicycle and this is a tricycle. एक बाइसिकल पे प्रॉफिट कितना आ रहा है, 65 रुपीज़, ओके, एंड एक ट्राइसिकल पे प्रॉफिट कितना आ रहा है, 45 रुपीज़, ओके, वेरी गुड, ओके. सो बट फॉर मैन्युफैक्चरिंग दिस बाइसिकल्स एंड ट्राइसिकल्स there are machine A and machine B, okay, through which these bicycles are processed, machine A and we have the machine B, okay. So understand very carefully. So let me put this 45 and 65 somewhere here. We will require these numbers at the end, okay. First let's formulate the LPP, formulate the linear programming, not a problem, okay. So for a bicycle, see here, where is it, yes, here, a manufacturing a bicycle requires, a bicycle मतलब एक bicycle requires 4 hours on a machine A, okay. For a bicycle machine A requires 4 hours and 10 hours on a machine B, 10 hours on a machine B. So ये हो गया अपना a bicycle का, okay. Next they have given that for a manufacturing a tricycle it requires 6 hours on a machine A and 3 hours on machine B. Is it okay? Perfect. Now there is one more sentence they have given that कि भाई वो मैन्युफैक्चरर के पास मशीन A अवेलेबल कितने टाइम के लिए है, it is available only for 120 hours, okay. So availability is how much? The machine A is available only for 120 hours and the machine B is available only for 180 hours. So in this way we can form the linear programming. Even though we have discussed these things in detail in the last class, I am explaining this once again because some students may find difficult, sir, where to put which variables and how to get this table, okay. Good. So I hope you have understood this. So what I have done, I have taken these variables, that is a bicycle and tricycle, from the last sentence. Always read the last sentence from which you will get these two variables which are there in the column, first row, okay. So maximum profit, you want to have the maximum profit. So this is all about, okay. Now to get the maximum profit and to effectively use these machines, देखो भाई रिसोर्सेज क्या है, अभी अपने पास रिसोर्सेज है मशीन ए एंड मशीन बी एंड दे आर अवेलेबल फॉर 120 आवर्स एंड 180 आवर्स. द मैन्युफैक्चरर वांट टू यूज द मशीन ए एंड मशीन बी इफेक्टिवली सच दैट ही शुड प्रोड्यूस और ही शुड मैन्युफैक्चर मैक्सिमम नंबर ऑफ बाइसिकल्स एंड मैक्सिमम नंबर ऑफ ट्राइसिकल्स टू गेट मैक्सिमम प्रॉफिट. आई होप यू आर गेटिंग दिस, ओके. ये रिसोर्सेस इफेक्टिव वे में यूज़ करके उसे मैक्सिमम नंबर ऑफ बाइसिकल्स और ट्राइसिकल्स प्रोड्यूस करने हैं, सो दैट ही विल गेट एट द एंड ऑफ द डे ही विल गेट द मैक्सिमम प्रॉफिट. दिस इज व्हाट द टोटल प्रॉब्लम इज, ओके. नाउ लेट्स अज्यूम दैट द मैन्युफैक्चरर इज मैन्युफैक्चरिंग एक्स नंबर ऑफ bicycles and y number of tricycles, okay. So let's write this. Let manufacturer produces x number of bicycles and y number of tricycles. So can you give me the first inequality which can satisfy the machine A availability, okay. So if one bicycle requires 4 hours, then x bicycles will require how many hours? Definitely it will require 4x hours. And one tricycle requires 6 hours, then y tricycles will require 6y hour. So total hour means what? It is 4x plus 6y. Now total available is how much? It is 120. Okay, total availability is how much? It is 120. Can you use the machine A more than 120 hours? No, it is not allowed, because in this question the maximum available is 120. Okay, maximum availability is how much? It's a 120 hours is availability maximum. So this should be less than or equals to 120. So this is for your machine A. Okay, now similarly we can form for a machine B. So tell me now, for machine B what will be the inequality? So it is 10x plus 3y. It should be less than or equals to how much? It is 180 hours. Okay, so this is what we get the inequality for machine A and machine B. Is it okay? And definitely these x and y's are what? These are the number of bicycles and tricycles. So can the x and y be negative numbers? No, definitely not. So I will put the third inequality as x is greater than or equals to 0 and y is greater than or equals to 0. ऐसा भी हो सकता है कि to get the maximum profit एक भी बाइसिकल मैन्युफैक्चर नहीं हो रहा है एंड पूरे के पूरे ट्राइसिकल्स मैन्युफैक्चर करके द मैन्युफैक्चरर इज गेटिंग द मैक्सिमम प्रॉफिट. दिस कुड आल्सो बी द केस. ओके, नाउ what will be the maximum profit in equation? What will be the maximum profit, equation? Okay, see, for one bicycle he is getting profit of 65 and for tricycle 45 rupees. So how many manufacturing we are? Bicycles 6xa and tricycles y. So to get the maximum profit, what we will do is I will have the 65x plus 45y. 65x plus 45y. So 65 and 45 are what? These are the that is the profit for a bicycle and a tricycle. Okay, good. So this is what we get the total profit. So let it denoted by the z. So this is as a total profit. Now what is your objective is to make the z maximum. So this is what my objective is. Okay, cool. So that's how we formulate the total linear programming problem. So still we have not solved for the number of x and number of bicycles and tricycles the manufacturing need to manufacture to get the maximum profit, but we have formulated the linear programming. So what are all equations are very important in this case is that the first one, the maximum profit. So this is what we get the first equation. This is what we get the second one, the third one, and these are the fourth ones. So total writing all these four inequations or equations will give you the full marks for this linear programming, formulating the linear programming. Please make sure that we are not solving this question. Solving means what? We have to find out the value of x and y. We are not solving, we are just formulating the linear programming problem. Okay, so in the next class we will be looking at the solution to this linear programming problem. So in this class we are just formulating the given questions. Okay, great. So this is what the final answer is. So final answer, how you will write? The maximum profit. Okay, so the total profit is, how we will write is total profit is z is equals to 65x plus 45y. Objective is what? Objective is to get z maximum, that is the maximum profit. What are the constraints you have or the resources you have is, for machine A we have 4x plus 6y. It is less than or equals to 120, and next we have is 10x plus 3y is less than or equals to 180. 10x plus 3y is less than or equals to 180. And what are the next constraints we have is x is of course it is greater than or equals to 0, and y is also same, greater than or equals to 0. So totally this will give you the full marks, maximum marks for the given question. Okay, writing all this, even though if you don't write these constraints also, you will lose half of the marks. I have already discussed this. Very important constraints these are. Okay, great. Now there are some terminologies which are very important to understand the given LPP. Okay, so let's say what are those terminologies are. So let me take the directly the number of terminologies here we have. So let's have, okay, so these are the terminologies which are very important as far as the any linear programming problem is concerned. The first one is the decision variable. Okay, the reason why I am taking the example first and explaining this theory part later, you will understand this. We will understand these terminologies with the help of just now solve the example. So decision variables are what? The variables involved in the linear programming problem are called the decision variables. मतलब क्या है? अगर मैं आपको ये पहले बताता और देन बाद में एग्जाम्पल सॉल्व करते तो इट विल वेरी डिफिकल्ट. ओके, सो डिसीजन वेरिएबल्स आर नथिंग बट इन दिस केस decision variables are what? The bicycles and tricycles. So the number of bicycles and tricycles will decide the maximum profit or minimum profit. So that's why the decision variables are the bicycles and tricycles in our previous example. Okay, so which decides the profit, okay, great. Objective function. Now tell me, what is your objective? I want to have the maximum z, maximum profit is my objective. That's it. That is nothing but the objective function. A linear function of variables which is to be optimized, that is either maximize or minimize, is called as objective function. So in the our previous example, so this z I want to make this maximum, so this becomes my objective function. What are the constraints? So constraints are nothing but the limitations. You cannot go beyond the given limits. Okay, so definitely these are the constraints you can see here in the previous example. So machine A and machine B maximum we can use for 120 hours and 180 hours. So that is what we have the constraints on the resources. Great. What about this non-negative constraints? Non-negative constraints we have already discussed in detail in my previous class. Okay, so non-negative constraints means x is greater than or equals to 0, y is greater than or equals to 0. So that's it all about the linear programming problem. I hope this example and the previous examples cleared your doubts. Now let's take one more example and let's try to formulate the same LPP. Okay, so let's take the second example. Again, important one and interesting. Okay, so in the next class you will find this topic is very interesting because we will be getting the values of x and y for which the manufacturer is getting maximum profit. Okay, great. Now let's read the first question and let's try to understand what the scenario they have given. A company manufactures two types of toys A and toys B, toy A and toy B. Okay, each toy A requires 2 minutes for cutting and 1 minute for assembling. Each toy of type B requires 3 minutes of cutting and 4 minutes of assembling. There are 3 hours available for cutting and 2 hours available for the assembling. Available means what भाई? ये हो गया अपने constraints. Okay. On this selling a toy of type A, the company gets a profit of 10 and the toy B profit of rupees 20. Formulate the linear program problem to maximize the profit. ये important है. Okay. Now I hope you have noted down what are the variables, what are the constraints, okay, and all those things. Always read the last sentence to get the decision variables. Decision variables means the number of toys or the number of units I want to manufacture. So in this case what are the decision variables? Maximum क्या करना है आपको? Profit कहाँ से मिलेगा आपको? type A toys and type B toys से मुझे profit मिल रहा है. So my type A and type B becomes the decision variables. Decision variables means these are the important. The number of these variables will decide the profit. Okay. Now what are the other variables or the constraints we have? Availability check करो भाई. Available. So availability किस पे है? So availability is for cutting and for the assembly. So let's write down cutting is my first constraint, cutting process is first constraint, and assembling process is my second constraint. Okay, now let's fill this table. So for toy A requires 2 minutes for cutting. Okay, so यहाँ पे टाइप ए एंड कटिंग के लिए 2 मिनट है, एंड फॉर असेंबलिंग 1 मिनट. ओके, एंड फॉर टाइप ए असेंबलिंग 1 मिनट. ओके, प्लीज़ मेक श्योर यू शुड बी वेरी केयरफुल वाइल फिलिंग दिस टेबल, क्योंकि क्या होता है कि ये 1 मिनट इधर किधर तो जा सकता है. ओके, दैट शुड नॉट हैपन. ईच टॉय ऑफ टाइप बी रिक्वायर्स 3 मिनट्स. सो टाइप बी रिक्वायर्स 3 मिनट्स फॉर कटिंग and 4 minutes for assembling. Very good. Now availability is there, so let's write down that availability. So 3 hours available for cutting, so 3 hours. Please make sure that these are in the minutes. Okay, these are in the minutes and this is in the 3 hours, so let's write in the minute also. So it's a 60 minute. And 2 hours for 3 hours, मतलब ये कितना हो गया भाई, 60 into 3, 180 minutes. So 180 minutes. Now 2 hours available for assembling. So 2 hours means how many minutes? It's 120 minutes. Okay, that's it. We have the table now. Now let's write down what is our objective function is. Objective function. So let's first write down the decision variables. So the decision variable is nothing but I will take this as a x and this as a y. The number of x, number of type A toys are x, number of type B toys are y. Let number of toys of type A are x and the number of toys of type B are y. Okay, now what is the profit function is? Profit function is equals to, so let's name this denoted by z. So profit function is what we have is 10 rupees for type A and 20 rupees for type B. Okay, so you can write the profit. So 10 rupees for type A, 10x, plus 20 rupees for type B. So that's how you get the profit function is. So 10 rupees for type A, so ये 10x हो गया, ये 20x हो, 20y हो गया. Okay, so this is what my profit function is. But what is your objective function? Objective function is nothing but I want to have the maximum of z. Maximum z is my profit function. Okay, now what are the constraints available with you? Constraints are nothing but, see what you will write, 2x plus 3y. So maximum availability is 180 minutes. So what is the inequality sign you will get? Of course I should get the less than or equals to. Maximum availability is 120 for assembling, so again you will get less than or equals to. Okay, so 2x plus 3y, the constraints are nothing but 2x plus 3y less than or equals to 180 minutes. No need to write down the units. Okay, then we have 1x plus 4y, that is 1x plus 4y is less than or equals to 120 minutes. Okay, ये हो गए मेरे constraints. Then what are your non-negative constraints? That is x is greater than or equals to 0 and y is greater than or equals to 0. So this is how my total linear programming problem formulation. Okay, formulation. Good. So formulation is very important to get the values of x and y. So in this class we are just looking at the formulation. In the next class we will be looking at the solution to these LPPs. Okay, great. Now let's see the next example and we will stop here. So क्या बोल रहा है, horticulture. Okay. Okay, let me paste this. Let's zoom it. Okay, now I hope it is visible. Cool. A horticulture wishes to mix two brands of fertilizers that will provide a minimum of 15 units of potash, 20 units of nitrate and 24 units of phosphate. Okay, see here, 15 units of potash, 20 units of nitrate and 24 units of potash. 1 unit of brand 1 provides 3 units of potash, 1 unit of nitrate and 3 units of potash phosphate, and unit of brand 2 provides 1 unit of potash, 5 units nitrate and 2 units phosphate. Okay, 1 unit of brand 1 costs 120 rupees and 1 unit of brand 2 cost 60 rupees per unit. Okay, formulate this LPP to minimize the cost. Now are you getting this? अभी ये खर्चा, this is what the costing is. It is not a benefit or it is not a profit, it is what we get the cost, total cost. Okay, he has to spend the 120 rupees for brand 1, okay, and 60 rupees he has to spend for brand 2. Okay, so of course if you are spending, that spending should be minimum. Now your objective function is what? I want to minimize this. So this is of the second type of example which I have discussed. So this is what you get, the 5000 rupees आपको spend करना है. Okay, so this is how, what is our objective is to get the minimum spending. So यहाँ पे भी same है. Okay, so from where you will get the objective, there's decision variables from where you will get, I will get it from the last sentence. Now let's read the last sentence once again. जिसका प्राइस दिया है ना वो आपके ऑब्जेक्टिव फंक्शंस रहेंगे. सो ब्रांड 1 एंड ब्रांड 2 का आपको कॉस्ट दिया है. सो लेट्स टेक द ब्रांड 1 एंड ब्रांड 2 एज द ऑब्जेक्टिव फंक्शंस, सॉरी ऑब्जेक्टिव वेरिएबल्स. नाउ व्हाट आर द कंस्ट्रेंट्स, व्हाट आर द अवेलेबिलिटी? So for availability, if you read the first sentence, you will understand. A horticulture wishes to mix 2 brands of a fertilizer that will provide a minimum of 15 units of potash, 20 units of nitrate and 24 units of phosphate. Okay, 1 unit of brand 1 requires 3 units of potash. So first variable is how much, what is your, it is a potash. My first constraint is on the potash. The next constraint is on the nitrate, so write down the nitrate. The third constraint is on the phosphate. Okay, great. अभी बताओ मुझे ब्रांड 1 के लिए क्या क्या चाहिए अपने पास. सो ब्रांड 1 के लिए 3 यूनिट्स ऑफ पोटैश चाहिए. सो 3 यूनिट्स ऑफ पोटैश लिख लो यहाँ पे. सो लेट्स मी यूज सम डिफरेंट कलर. सो इट रिक्वायर्स 3 यूनिट्स ऑफ पोटैश. And nitrate, how much? It is 1 unit nitrate and 3 units again phosphate. And for brand 2, now 1 unit of potash, 5 units of nitrate and 2 units of phosphate. Okay, great. Now what is the total availability? How much potash, nitrate and phosphate available? Minimum 15 units of potash. Minimum matlab you have to use minimum 15 units of potash. Okay, minimum. So what the sign you will get here? Minimum 15, you can utilize maximum or more than the 15. So it will be greater than or equals to sign you will get here. What about the next step? So the minimum you have the 20 units of nitrate and 24 units of phosphate. So for all you will get the greater than or equals to sign. I hope you are understanding or you are getting why I have given the sign greater than or equals to, because it requires here a horticulture mixes 2 brands to that will provide minimum, it is going to provide minimum 50 units. So कमित कमी अगर 15 दे रहा है तो ज़्यादा से ज़्यादा कितना? So of course it will give me 15 or more than 15. That's why I have written the constraints like this. Great. So once you get this, your half of the task is done. Now next you can write down the costing, or you can write down the profit here. So not profit, it is the cost we can write. So let's write down the cost here so that it will be easy for us to get the equation right here only. So cost is 1 in brand 1 का cost कितना है? इसका 120 रहेगा cost brand 1 का. ओके, ब्रांड 2 का कॉस्ट कितना है, इट्स 60 रुपीज. ओके, लेट्स हैव नाउ the variables. So this is my first decision variable, this is my second decision variable. Let's have the profit function. So the profit function will be what now? Profit function. So profit function will be what? It is equals to z, which is equals to 120x plus 60y. This is my profit function. And what is your objective function is? My objective is what? You want to make z as maximum or minimum. I want to make the z as minimum as possible because I am spending these many rupees. Okay, so I want to have minimum of this z. So this becomes my objective functions. What are the constraints you have? So I have the constraint as 3x plus y. First constraint I am writing for potash. It is greater than or equals to 15. Second constraint is x plus 5y is greater than or equals to 20. And the third constraint I am writing as 3x plus 2y, which is greater than or equals to 24. So these are what constraints I have. Okay, so if x and y are the brand 1 and brand 2, can these values be negative? Of course not. So the last constraint, which are non-negative constraints, I can write as y is greater than or equals to 0 and x is also same, greater than or equals to 0. So this is how the total formulation of your LPP, formulation of your total LPP. Okay, so I hope you have understood this, and in the coming classes we will be looking the exercise. What are the questions are there in the exercise we will solve? All are very simple. If you understand this video, this class notes, then you will require hardly 30 minutes to solve these 10 questions which are there in your exercise 7.3. Okay, so in the next class we will be looking at the 7.3, and after that in the next classes we will be looking at the solutions to the linear programming problems. Okay, so I hope you have enjoyed this video. So with this we will stop here. We'll meet in the next class. Thank you.